All right, let's begin. So, thank you everyone for joining this workshop on Blender. This workshop has been organized by the MN FARUQI Innovation Center, which has been set up at IIT Kharagpur by Mr. Arjun Malhotra, who was the co-founder of HCL and a very distinguished alumnus of our institute. The center has been founded in the name of Professor MN FARUQI, Mohammad Nasim FARUQI, who was also the Deputy Director of IIT Kharagpur, and more importantly, a professor at the Department of Electronics, who always promoted the use of up-to-date technology and who promoted very modern infrastructure for everyone. In view of this, the center had been set up in his name so that people can undertake various projects, they can tinker around, they can fabricate, and they get a funding from the center to undertake these activities. Blender is a very versatile tool. It's open source and it has found a lot of use in many animations and in many places which have integrated augmented reality and virtual reality. It has been growing non-stop ever since its inception, and it is expected that Blender will incorporate more and more features to make life easy for both creators and artists. Nowadays, it has also found use for engineers as well. It has a very tight integration with Python, owing which one can actually have a lot of automation in its workflow. Today's presenter is Shreyansh, who is an expert in Blender, and I hope all of you will take a lot of interest in today's and tomorrow's demonstration and workshop so that you can also learn this software along with him. By along with him, I mean work along while he's showing various things. And hopefully you will find Blender very useful for your day-to-day applications and work. With this, I hand over the stage to Shreyansh. Thank you, Shreyansh.
Thank you, sir. Thanks a lot for the introduction. Hey everyone. So, yeah, as sir introduced, we are going to be exploring the software called Blender, and so a lot of you might be thinking, what's so special about the software, and why are we trying to learn it? Or some of you might also know about Blender from earlier, but let's just look into why Blender is such an interesting piece of software. Let me share my screen again. Is it visible? So, so yeah, let me show you a couple of pictures, and then we can talk about them. So let's look at this picture. This is a photograph of a honeybee, and we can see all the little details, all the little droplets, all the little hairs on the honeybee. And this is a picture of a street, and it's very well lit, and you can see that the composition is very aesthetic. This is a picture of a forest, of a bridge in particular in a forest, and you can see all the ferns and all the grass and the trees growing around. And this is a picture of a car. But why did I show you all these pictures? These are not actually photographs. These are actually computer generated imagery. So, what is computer generated imagery? So, computer generated imagery is basically any image that a computer synthesizes. So, each pixel of this image is actually an output of an algorithm from a computer. So, Blender is one such tool that we can use to create like very beautiful computer generated imagery. If you open up Blender's homepage, so you can see the various uses of Blender. You can see that it has a cycles render engine, which we can use to create beautiful images. We can use it to model, sculpt, and UV unwrap 3D models to create assets. So if you're not familiar with what assets are, we will get more familiar with these terms as we go along the workshop. So we can use Blender to create 3D models. We can sculpt 3D models. We can UV unwrap 3D models. We can use Blender for VFX. Blender is used in VFX industries. It is used for creating animations, for creating rigged characters. So whenever you need to animate, the character needs to be rigged properly for easy animation. So we can use Blender to create rigged characters. We can use Blender to create 2D and 3D art and animate them, and much more. You can even use Blender for video editing. So Blender and like Sir mentioned, it also has a Python API and it's very powerful. So Blender has a lot of uses, and it is very versatile. So today we'll be looking only at one of the possible uses, which is 3D rendering and 3D art creation. So let's look at how CGI works. So behind the scenes, behind those computer generated imagery, what is going on is that, so this is a screenshot from Blender. In Blender, we have light sources, we have objects, and we have cameras. So what happens is light emitted from the light sources bounces off the objects and it enters the virtual camera. And once it enters the virtual camera, that is where the image is formed, and this process is called rendering. So it's very simple. Like even in real life, this is basically how we perform photography. Let me switch to, yeah. So even in real life, this is how we perform photography. We have light sources, we have objects to photograph, and we have a camera. And it is very similar to how we do it in real life. And we have a virtual light source in Blender, we have a virtual object, and we have a virtual camera. So if you have heard of the Cornell box, it's basically a box. It's a real life box developed in Cornell, which had one wall painted green and the other wall painted red, and it had various objects kept inside it, a hole at the top wall, and a light source fitted on that hole. So this box was used to study light transport in detail, but we don't need to discuss about that very much. But I just kept here to show that we can use Blender to model real life scenes in a virtual format. So this box is an actual box that was developed at Cornell, and you can see that we have recreated it in Blender, and it looks just like it would look in reality. So how do we create such virtual scenes? What is the process of like going from a blank canvas to a beautifully rendered image using Blender? So that is what we'll be discussing in the following slides now. So the first step is modeling. How do we model? How do we create the virtual object that we want to render? So we do that by creating a 3D mesh of that object. To create a 3D mesh, we have in a 3D mesh we have vertices, we have edges, and we have faces, and all of these combined give us a 3D mesh. There are different types of modeling, like different ways, different methods we can use to get from one point to the another to get to the finished product, like box modeling, sculpting, hard surface modeling. We don't need to get into the detail of these. We'll be discussing box modeling in our workshop, but you can look into sculpting and hard surface modeling. They are very powerful tools to model organic. Sculpting is a very powerful tool to model organic looking objects, And hard surface modeling is a very powerful tool to model very machined objects. So so this is what modeling is. It's kind of similar to CAD if you have had any experience with CAD. It's similar to CAD in the sense that we are creating a 3D object, but it has a few differences. It has a few key differences with CAD. So what are the differences with like when we model using CAD versus when we model using Blender? So in CAD, we don't really care about the topology of the surface, in the sense that we don't really care about where the individual faces are, where the individual triangles are, where the individual vertices are. We only care about the shape of the surface and whether it's correct. But in Blender, it is a bit more complex than that. We'll have to care about even the like where the vertices are going, where are the faces, where are the normals pointing. These things are things we'll have to keep in mind while modeling in Blender. So this is how it's different in CAD versus Blender. So what do I mean by topology? To give you a rough idea, we take a look at this cube on the left, the mesh of this cube, and the mesh of this cube on the right. So in general, you can get a feeling that this is a good topology. It's very uniform, and you can see how the geometry is flowing. Whereas in this cube, it's very chaotic, and you don't really get a sense of like it's very chaotic in general. So that's the basic idea with which we'll be referring to topology in this workshop, and you'll get a better feel for it once you start finishing your modeling skills. So, so these are the examples of the things that you can kind of create using modeling, and you can basically create any kind of mesh that you want using like by modeling it in Blender. So, do you have any doubts up till now? If you have any doubts, you can either unmute yourself and speak up, or you can write it in the chat.
Is it possible, anyway, that we can include CAD models in, like we can import CAD models in Blender?
Yes, it is possible. Like you can export CAD models as STL files in most CAD modeling programs, and in Blender you can import STL files. So that is possible. So you asked if Blender is free, or is there a student version for Blender? So Blender is free and open source, and you can go ahead and download it from blender.org/download if you haven't done that already. I'm gonna paste that link on the chat again, and you can go here and download Blender from this link, and you can start the installation process right now. So that while we finish this section, you can Blender is installed in your computer, and you can start with a little bit of hands-on. Okay, so someone asked if so. Could you please explain once again the difference between CAD modeling and Blender modeling? So yeah, so in CAD modeling, you are not concerned with where your faces are going. So for example, if you look at this, if you look at the image on the right, even this single plane surface, the single plane square surface has multiple faces. It is made up of multiple faces. This is a single face. This trapezoid is a single face. This trapezoid is a single face. It's not really a trapezoid. So this quadrilateral is a single face, and each of these segments is a single face. But here we are not really concerned with where the vertices are. So there are vertices along this edge as well. This is a vertex, this is a vertex, this is a vertex. But here we are not concerned in the CAD in modeling. While modeling in CAD, we are not concerned with where the vertices are going. I hope that makes a little bit sense. Now there are exceptions to this, like of course, but this is the general idea. Did I answer your question? Okay, so the follow-up question is that dimension has any importance. Could you explain what do you mean by that question? In CAD, dimensions are there. I'm still not sure what you mean by that question. Oh, okay. Okay, so you're asking if you can be like dimensionally accurate. You can have accurate dimensions in Blender. So in CAD, definitely you have you can make accurate dimension models. In Blender also you can make it accurately, but the focus is not on creating accurate real life size models or things like that. It's the focus in Blender is more on um, a little bit more towards the creator side. So you can definitely do that, but it's a little bit more work than if you were to do it in a CAD. Mhm. Okay, so we'll move on to the next section. So the next section is unwrapping and texturing. So once you have your virtual object as a 3D mesh, how do you add color to that object? How do you know which point in that object should be of which color? To do that, we have the process of unwrapping and texturing. So if you want to, let's say, make that Minecraft cube, how would you go about doing that? So one way to think about it is to imagine that you cut along the edges of the cube such that the faces of the cube open up flat onto the ground and you get a shape like this. So once you get a shape like this, you can overlay an image on top of it, and then when you fold it back, something like this happens. So once you have cut your cube open flat out onto the ground, and you overlay an image on top of it, and then you view your cube back in 3 dimensions, you can see that that image is applied onto the cube by with the help of this unwrap that you created. So this unwrap is what we call the UV unwrap of this 3D mesh. So does that make sense? So if at any point you think you are facing any doubts, you can either unmute yourself and ask the doubt, or you can write it in the chat. And at the end of each section, I'll check the chat for any doubts. So moving on to the next section, we have PBR rendering. So what is PBR rendering? PBR rendering is basically once you have textured your mesh, once you have added color to your mesh, now we want to dictate how it behaves with respect to light. So PBR stands for physically based rendering. So once you have added color to your mesh, it does not necessarily mean that color is the only thing that defines what a surface looks like. For example, a blue wall will look different from a blue glass wall or a blue glass door. So each surface has these properties associated with it: roughness, metallicity, specularity, anisotropy, emission, transmission, and there are a lot more. So each surface has these properties associated with it, and to recreate this surface in Blender or in any virtual scene, all we have to do is plug in the correct values for these material parameters, and what we will get is a faithful recreation of that surface in 3D in our 3D software like Blender. So just to give you an example, if you just consider these two properties, roughness and metallicity, you can look at how the appearance of a sphere changes as we increase the roughness or decrease the roughness while increasing the metallicity or decreasing the metallicity. So you can look at you can look at this sphere, which is very metallic and slightly rough, and it looks a very metal-like sphere. And you can look at this sphere, which is very non-metallic and very rough, and it looks a very diffuse sphere, as if it was made of concrete. And you can look at this sphere, which is very slightly metallic, but very smooth, and it looks like something made of porcelain. So this is how these material parameters dictate what the surface will look like. And in these spheres, I have not changed any lighting conditions. All the only thing I've changed is the roughness and metallicity, and I haven't even changed the color of the sphere. So this diagram shows you how light interacts. I think it's slightly out of the scope of this workshop, but it's still a little bit intriguing to look at. And if you find interest, you can look for diffuse reflections versus specular reflections, and you can Google search for them, and you can find more information on that. So just to give you an example, this cube is what it would look like before it has been rendered, before we have added lights to it, before we have gone through the process of PBR rendering. And once we go through the process of rendering, once we add lights to the scene, once we add cameras, once we actually render the scene, this is what it would look like. So you see the extreme jump in photorealism just due to the accurate interaction of light with the surface, just due to simulating the accurate interaction of light with the surface. So this was basically how we create virtual scenes, how the process of CGI takes place. And now I think, so if you have all installed Blender, we can open up Blender and we can start looking around Blender a little bit. Before that, let me just check for any doubts in the chat, or if you have any doubts right now, you can also unmute yourself and speak up.
Since PBR means physical based rendering, so why is there PBR rendering? Like, is it generally that only, or do you call it PB rendering something?
Yeah, it's that only. It's generally
Just a silly question from my side.
yeah. So it's just PBR. So the R refers to rendering itself. But once you write while speaking, people usually speak PBR rendering. So that is why I wrote the title like that.
Okay, cool. Thanks.
Okay, so let's move on to Blender now. Let's open up Blender, and so I hope you all have installed Blender already. If not, then please put it on install right now, and hopefully you'll be able to follow along. So today we'll not do a lot of hands-on. Mostly the hands-on part we'll be doing tomorrow. If you want, you can carry along with me. I'll be explaining what the interface of Blender is and how we usually use it, and getting you familiar with Blender in general. So yeah, let me open my shortcut viewer, and so you can look at whatever keys I'm pressing on the bottom right of the screen. For example, right now I'm using my middle mouse button to move around, and I'm using, so right now I press space. So yeah, this is how you can look at what I'm doing with my keyboard and my mouse. So once you start up Blender, you will get a splash screen saying what is the asking you what do you want to keep the key maps to. Personally, I have set my key maps as right click as the select button, because I've been using Blender for a long time, and earlier it was like right click, so I have that as a habit, and I have kept search as the spacebar action, again because it's from the previous versions of Blender. But if you are starting out with Blender, you might want to keep it with a left click, or you want to keep it, and might want to keep the spacebar to play. So suit yourself, but this is what my preferences are. If you want to follow along religiously, um, yeah. So this is the startup screen that we see on Blender. It is very simple. We have a cube, we have a light source, and we have a camera. How am I moving around in Blender? You can move around Blender, like you can move your viewport camera around using the middle mouse button. You can see over here, I'm clicking and holding the middle mouse button and moving around. So this is how you move the camera that you use to view the scene in Blender. So the screen that opens up in Blender is called the viewport. This section over here, this whole section is the viewport. Yeah. So this is the viewport, and currently we are in the layout view, in the layout workspace. So you see there are various workspaces in Blender. These are not any special workspaces. So what I mean to say by that is, let's say you want to model an object, so you want to edit an object. You can do that by going into the modeling workspace or into this sculpting workspace, but it's not necessary to do that in these workspaces only. You can even do that in the layout workspace. How we can do that, I'll tell you in a few in a few minutes. So just like that, we have the shading workspace, we have the texture paint workspace, the animation workspace, and we have the rendering workspace. So we have various workspaces in Blender. But like I said, you don't need any of these workspaces as such. You can, for example, you can create the shading workspace by splitting the screen in half. So how do you split the screen in half? So if you look at this, if you look at the boundary of this window and this section and this section, on the top of that boundary, you see your cursor will turn into a crosshair type of cursor. So if you are in that crosshair cursor, move slightly to the left so that your cursor is closer to the viewport window rather than the window on the right side, like this, and drag down. So this will split your screen in half, and both of these are now the viewport, and any changes excuse me, any changes that you do in this viewport will be reflected in the other as well. So this is how you can customize your Blender screen. And so right now the section above is also a viewport, and the section below is also a viewport. We can change the section below to look more like the shading workspace by changing this from the, so if you click on this button, next to the object mode, you can see the various windows that Blender has. And if you go to the shader editor, if you go and select the shader editor over here, this looks now much more like what we have in the shading workspace, right? So this is how you can customize your workspace in Blender. Now let's say I want to get rid of this shading workspace. How do I do that? So again, to get rid of this workspace, we need to go on the boundary of this of the section above and the section below, this boundary, and on the edge we'll see that our and on the, like, right at the end of it, we'll see that our cursor turns into a crosshair. We move our cursor slightly closer to the window, to the above window, and we click and drag down. So this basically tells Blender that we want to like remove the lower section. So that's how you remove the lower section. So I hope this is clear up till now. Do you have any doubts? Again, if you have Blender and you are trying to follow along, it would help a lot with whatever I am speaking. Okay, since there are no doubts, let's move forward. So let's now look at how we can edit an object. So this is an object that's already in our scene. How do we edit it? Currently it's in object mode. Currently we are in object mode, so we can't really edit this object. To edit this object, we need to select this object first. To select this object, we need to right click, we need to left click on it if you have selected the left click preference, or right click on it if you have selected the right click preference. So select this object and go to edit mode. And now you can see that we have a different kind of view, and in this we can edit the object. I haven't really told you how we can move these things around, but how we can move these vertices around, but we'll get to that in a moment. So I just press control. I just pressed Control Z for until I got my cube back. Let's go back to object mode and let's look at how we can move or rotate or scale objects in Blender. So to move objects, we can either do that using this move tool. First we select the object, then we click on the move tool on the left. And once we click on the move tool, we get this little gizmo which helps us move this object around the X, Y, and Z axis. Or we can use these little planes to move the object in that specific plane. So this is how we can move the object. We can translate it using the gizmo. We can also rotate the object using this gizmo, the one below move, and we can use this to rotate the object. We just need to click on the axis that we want to rotate it along and move our cursor along that axis. So this is how you rotate the object. Let me undo that operation. I just press Ctrl Z. And if you want to go back to the normal selection mode, then you just press this, you just select the select box. Right. So yeah, so there are also shortcuts that you can use to move the object, and I highly recommend that you use shortcuts. You start incorporating shortcuts in your Blender workflow, because they will increase the speed of your Blender, how you work in Blender by 10 times. So shortcuts are really important in Blender if you want to work quickly. So how do we move objects using a shortcut? To move this cube, all you have to do is select it and press G on the keyboard. Once you press G, the cube will be locked to your cursor. Now if you want to move the cube, let's say along the Z axis, then just tap Z on the keyboard and you can move the cube along the Z axis. Or let's say you want to move it along the X axis, then just tap X and you can move it along X axis. And similarly you can tap Y to move it along the Y axis. You can also, so let's say you want to move the cube in the XY plane. So if you want to move it in the XY plane, then you press Shift Z, because you don't want to move it in the Z direction. And if you don't want to move it in the X direction, you want to move it in the YZ plane, then you press Shift X and now it moves in the YZ plane. And similarly Shift Y will give you the movement in XZ plane. So that is how you move the object using using shortcuts. So let's say we want to move this object a little bit up. So once you move it a little bit up, then instead of so if you want to like if you're happy with the movement, then just left click and the object will move that much amount. But if you're unhappy with the movement, let's say I move the object over here, and I'm unhappy with the movement, then I can press right click and it will cancel the operation. So that is how you move objects. Similarly, you can use the R key to rotate the object. R is the shortcut for rotation, and if you press it, it will try to rotate it along your view direction. If you want to rotate it along the x direction, you can press X. If you want to rotate it along the y axis, you can press Y. Along the z axis, you can press Z. So that is how you perform rotation using shortcut. And again, if you want to, if you're happy with the rotation, you can left click to confirm. And if you're unhappy with the rotation, you can right click to cancel the operation. So yeah, this is how you performs rotation and move translation of an object in Blender. You can also perform the scale operation by either selecting the scale gizmo over here and moving it and scaling it around different axes, or you can press the S key on the keyboard and you can scale it along all the axes at once, or you can scale it along the X by pressing X, or you can scale it along the Y by pressing Y, or scale it along the Z by pressing Z, or you can even scale it in the XY plane itself by pressing Shift Z, in the YZ plane by pressing Shift X, and in the XZ plane by pressing Shift Y. So I hope that makes sense for now. And so if you find it difficult to move objects around and you don't get the hang of it right away, don't worry, it takes a little bit of practice, but once you get familiar with it, it will become second nature to you. So now let's look into how we can edit this object. Now that we know how to scale, how to rotate, how to move. So even in the edit mode, so just select your object and go to the edit mode. And in the edit mode, let's say I want to move this vertex upwards. How do we do that? We first select that vertex by using the select mouse button. For me it's right click, for you it might be left click. And then we press G and Z if you want to move it in the Z direction. So you remember G was the shortcut for moving it, so for translating something, right? Those shortcuts are valid even in the edit mode. So if you move it, if you press G and Z, then press Z, you can move it along the Z direction. If you press X, you can move it along the X direction. Press Y and you can move it along the Y direction. So let's say I'm happy with this movement, and let's say I want to move this along the Y as well. I press G and then I press Z, and now I have something that looks like this. So this is how you can edit the meshes. So, but let's say that you want to start from scratch. How do you add something to your scene? To add anything in the 3D viewport, all you have to do is press Shift A, and then you get this add drop down or add dialog box, and inside this you can see you can add a lot of things. Currently we are just going to add let's add a UV sphere. So this is what a UV sphere looks like, and we have added it to our scene now just by pressing Shift A and selecting it from this menu. But so if you want, so let's say you want this UV sphere to be added over here, right? Let's say we want that UV sphere to be added over somewhere over here. You can do that either by adding it on the origin and then moving it along the x-axis, yeah, moving it along the x-axis, so it ends up there. Or you can do something else so that it appears directly over there. To delete an object, you just press delete on the keyboard, or you can press X and then it will ask whether you want to delete it. So to directly spawn an object at some point, all you have to do is click on that point, and this circular gizmo will move to that point, and that will determine where the next added object will spawn. So now if I add a UV sphere, it will spawn over here. And if I move the 3D cursor, so this is what we call this as the 3D cursor. If I move the 3D cursor to some place over here, you can see where the 3D cursor is. And if I add a cube, it will spawn over there. So this is how you can add more objects to your scene. Right. Okay, so let's quickly discuss how we can start modeling things in Blender. So let's click on the cube. Let's select the cube and enter its edit mode. So to enter the edit mode, you can either go from here and select edit mode, or you can just press tab on your keyboard and you can enter the edit mode. Now let's look at the different parts of this cube's mesh. To view the cube's mesh in a more complete way, we can hold Z on our keyboard and move our mouse to the wireframe section. And in this way, we can look at the entire mesh of the cube in a wireframe manner. So you can see that the mesh has vertices. These are the vertices that I'm selecting right now, and it has edges. So two adjacent vertices create an edge. So I'm selecting this edge right now, and you can select an edge by selecting its two end vertices. That is how you select edges. And it also has faces. So let's say this top face. You can select this top face by selecting all its 4 vertices. So you can in general select a face by selecting all its bounding vertices. So that is basically how meshes are composed of. They are composed of vertices, edges, and faces. To give you an idea, so you might think that any adjacent 4 vertices will make a face, but that is not the case. Like we can delete this face. If we select the 4 vertices, we can delete this face. If we press delete, we get the option of deleting the vertices, edges, faces, only edges and faces, only faces. So if you select only faces, it will delete the face, but it will leave the vertices there and it will leave the edges there. So now you don't have the face, but you have the bounding vertices and the bounding edges. So let's Control Z and look at look at what happens if we select faces. If we select faces, again a similar thing happened, but if we delete the vertices, the entire top all that we are left with is a single plane, and the entire cube is gone, because once we delete the vertices, there is nothing for these vertices to connect to. So once we delete these vertices, there are no vertical edges, there are no vertical faces, there is no top face. So if you delete if you delete vertices, you delete more information from the mesh, is basically one way to put it. Right, so meshes are composed of vertices and edges and faces. Let's look at how we can add more geometry to this mesh. We can even move faces by selecting a face and then pressing the shortcut G, and then selecting the axis that we want to move it along. For example, x-axis, z-axis, or the y-axis. So let's say I want to make this cube a little flatter. We can also add additional geometry to the cube by extruding this face. What do I mean by extruding the face? To extrude a face, press the shortcut key E. So once you press E, you see a new face will appear and it will get logged onto your cursor, and like wherever you move the cursor, it will follow your cursor. And once you are satisfied with where you want to place this new face, you can just left click, and that will lock that face onto the position. So what benefit do you get by adding this extra geometry, adding these extra vertices? You can now if I select the topmost face and if I move it, I get a shape like this. So instead of getting just something like instead of getting something like that, now I have an extended portion, and then I can extrude this portion and then move it along the Y as well. And you can see how we can start to create complex objects just by extruding and moving vertices around. So let's say I want to move this vertex in this direction, move this vertex in this direction, and move these vertices in the X direction over here. So you can see that we can start to create very complex objects just by extruding and moving vertices around. So yeah, this is basically what extruding means. We are basically taking a face. And we are duplicating it, but also connecting all its edges to the original face in order to create vertical faces. That is what basically extruding is. It will be a little easier to understand if you have like performed any CAD modeling before, since extruding is very common there as well. But even if you are not very experienced in this, it's not very complicated to understand. Like, it's pretty simple. It's just like creating a copy of the face and attaching it to the original face. So, right. And let's say that you don't want to. Let's say I have this geometry over here, and I don't want to extrude it. Rather, I want a geometry to appear. I want some vertices to appear along this cuboid, something like this. How can I do that? To do that, all you have to do is press Ctrl R. That's the keyboard shortcut, Ctrl R, and move your cursor near an edge, and it will show you it will show you a tentative cut along the geometry of like whatever you're trying to add a cut to. So these cuts are what we call loop cuts, because you can see that this cut is in the shape of a loop. And if you add this, and if you left click, then this cut is realized, and then you can slide it around along the geometry to like finally place it wherever you want to place it. So let's say I want to place it a little bit below where I initially where the cut was initialized from. And now that I have press the left mouse button and finalize this cut, I have a loop cut available for me. And now if I want to move it along some axis, I can move it along some axis, and now I have a different shape. So this is how you can add loop cuts to your geometry. So all I'm doing is just like adding loop cuts and moving and pressing G on the keyboard and moving these around. Nothing very complicated going on here. So I hope it's like clear up till now. Is there any like doubts? Oh, okay. So there are some questions in the chat. Vertex only is moving. How do you deselect it and move the cube as a whole? To deselect a vertex, just click away from it. Let's say I have this vertex selected. Now to deselect it, I just want to click away from it and it will get deselected. And if you want to select the entire cube, you can press in the edit mode, you can press A. In the edit mode, if you press A, you select the entire cube. So yeah, and if you want to deselect it, you just click away and it gets deselected. And if you want to move the entire cube in the object mode, then just go back to object mode by pressing tab. If you press tab, if you pay attention over here, I press tab and now we are back in object mode. And then you can't really select the individual vertices. You will have to move the cube as whole itself. So yeah, I hope that answers your question. The next question is how to toggle selection between vertex and face. Okay, so you can either select a face by selecting all of the bounding vertices. You select all the bounding vertices, this face gets highlighted, which means it's selected. Or you can press 1 on your keyboard to enter the vertex select mode, which we are currently in right now. 2 on the keyboard to enter the edge select mode, which looks something like this. So you can see that I'm selecting edges. And even in this mode, you can select the faces by selecting all the bounding edges. But if you press 3 on the keyboard, you will enter the face select mode. And in this mode, you can click on faces and the entire face will get selected. And in this mode, you can't select edges or vertices individually. So I'll press 1 again and I'll go back to vertex select mode. I hope that answers your question. Right, so there's only one more thing that needs to be discussed in modeling, is that how do you duplicate something? Let's say we have this. Let's go to face select mode by pressing 3 and select this face. Now instead of extruding it upward, I want to duplicate it. How do we do that? So to duplicate it, all you have to do is press Shift D on the keyboard. Shift D is the shortcut for duplicating, and now a duplicate of this face is logged onto your cursor and you can place it wherever you want. If you want to duplicate a bigger part of the cube, you can select that as well. Let's say I want to duplicate this part of the cube. Duplicate that, just select it and press Shift D and it gets duplicated and gets logged onto your cursor and you can move it away. So this is how you create duplicates. So all of this I'm doing in edit mode because you can't really access the individual edges, vertices or faces in the object mode. You can only access them in edit mode. Now if I press tab and go back to object mode, you can see that these different pieces of mesh are in the same object. I have only selected this cube and these meshes are also getting selected with it. The reason for that is that we duplicated them in edit mode. So when we duplicate, so whatever we do in edit mode, even if we add new meshes in edit mode and move them around, they will still be part of this cube. All of these meshes are part of this cube object. If we want to separate them, we can separate them, but right now they are just part of this cube object. So if I move this around, they all will move around with it. If I want to move them around individually, then either I'll have to go in edit mode and select that geometry and move them around, move those vertices around, select this geometry, move this face around, select this geometry, move it around. You want to select that. If you want to unselect something, you can just, so let's say I selected this by mistake. If I want to unselect something, I can just press shift and select button again, and you can do and you can do that. Shift clicking will also work for like selecting unselected things. So if something is selected, it'll get unselected. If it is unselected, it will get selected just by pressing shift and select button. And I can move this part around as well. But once I'm in object mode, they are a single object. I can't move them around anymore. Like can't move them around individually anymore. So those are the modeling basics. Let's delete this cube that we made. Bring our sphere somewhere about in the center, and let's start working on this. So I'm zooming into the scene by scrolling my mouse wheel, and so one handy tip that you can use to like maneuver around the viewport is you press shift and middle mouse button, you can pan around the viewport. So it will help you move around the viewport more easily. So you can pan around the viewport, bring your sphere to the center of the screen, then orbit around the sphere, see if it is really in center. And so it seems to be in center right now. So I'll start work on it. So currently you can see the sphere is made up of many faces. But once we render it, we don't want to see all these faces. So one way to combat that is by adding more and more geometry to smooth it out. So, but if we add a lot of geometry, then our computer will like find it difficult to process the information, to process this large amount of geometry. So a workaround for that is you can select the sphere, you can go to the object object drop down in the top left, and you can select shade smooth. So it won't change the number of faces, the number of vertices in your sphere, but your sphere will start to look like a lot smoother. So you can see that it starts to look a lot smoother. So how does it do that? It basically interpolates between the normals of the faces and calculates the shading using the interpolated normal vectors rather than the face normal vectors, the absolute normals. So that is why it looks a lot smoother. So once we have made our sphere a lot smoother without increasing the number of faces, we can go ahead and try to add color to it and see how it looks. So is there any question up till now? Okay, sir. Okay, there are a few questions. How to toggle selection between vertex and face? Okay, so I think I answered that already. The next question is middle button of my mouse is not moving. Is there any other way to move the plane? Okay, so there are other ways to move the plane. You can go to edit preferences, and you can right, there was so in the input there should be a emulate 3 button mouse. So in the input tab there should be an emulate 3 button mouse, and if you select that and you save preferences, you can use alt, you can hold alt on the keyboard and left click on your mouse to move around, and you can select and you can press shift alt to pan around. Shift alt and left click to pan around, and alt to move around, alt click to move around. So I think that should be helpful a little bit. That should also help the laptop users who don't have an external mouse. So for me, I'm going to disable this for now and save my preferences. Okay. So let's move on to adding some lighting in the scene. Uh, so so currently all we are seeing is the sphere as it is rendered in Blender's default. So currently it's rendered without any lighting. I mean it's rendered uh, with lighting with respect to the camera. So this is not how your sphere would look like if you render it. This is just the viewport shading. To get a preview of what your sphere will look like if you render it, you can hold Z on your keyboard and go and move your mouse up until you hit the render, and then leave the Z on your keyboard, Z key on your keyboard. And now we have entered the rendered view. You can see that since we have the light source over here, our sphere is getting illuminated by the light source in this manner. And if you move the light source around by pressing G, you can see that the sphere reacts to the motion of the light source. So in Blender, you can perform rendering in a few ways. So let's go back to the viewport view by pressing Z and moving our cursor to the solid button, and then leaving Z. Let's bring our sphere a little bit up until it's above the ground plane. Let's bring our cursor back to the origin, somewhere around the origin. Let's just click over here and I think it should be there. Right. And then let's add a new plane by pressing Shift A and plane. So Shift A, mesh and plane. So that is how you add a new plane. And then you can sorry. And then you can enlarge the plane by pressing S and then moving your mouse, and that is how you enlarge the plane. So now if you render, you can see the shadow of the sphere on the plane. So what I want to bring your notice to right now is if you go on the right side of the Blender screen, there is the hierarchy section on the top, and we have the rendering options. We have the different properties panel on the bottom section. Right. So we have the different properties panel on the bottom section, and in the bottom section we have this render properties tab. So select that tab, and you'll see these render properties pop up on the right side. Sorry. So currently the render engine that we are using is Eevee. We can change this render engine by selecting Eevee, by clicking on this drop down and selecting cycles. So if you select cycles, then you would see that your scene slightly changes. It looks mostly the same, but it looks a little bit better than what it was in Eevee. The reason for that is cycles is actually a ray tracer. It's actually a path tracer. So cycles actually simulates the light rays, like moving out of the light source, hitting the plane, bouncing off the plane, bouncing off the sphere, hitting the camera, and it performs these calculations very accurately. And that is why what you're looking at right now is a is an image which is much closer to what it would look like in reality. Whereas if you move back to Eevee, it looks slightly less photorealistic now, but it renders much faster. Like you can move around the scene very quickly. And if you go back to cycles, you'll see that moving around the scene is a little bit jarring. So So that is the difference between the two render engines that we have. Let's go back to EV for now, and then we can try to add a little bit of surface properties to the sphere and see how it looks sorry, with our two render engines. So to do that, we first go to the shading workspace. You can also, like I said, you can also create a shading workspace for your on your own, even in the layout workspace, but it's just more convenient to switch quickly to the shading workspace and back to the layout workspace. So let's move to the shading workspace. And before that, do you guys have any doubt till now? Okay, so since I think no one has any doubt till now, let's go back and let's look at the shading workspace. So currently in the shading workspace, we are looking at an environment, and our scene is embedded inside that environment. So this Blender does that so you can get a better feel of what it would look like with natural lighting. But right now we don't want to look at our scene with natural lighting. So let's just press Z and move it from material preview back to rendered. So now we are in the rendered view, and we have our scene like we had in the layout view. But we also have this section on the bottom, and this section is called the shader editor. So how does the shader editor work? To use the shader editor, first we'll have to select an object. Let's say I want to add a shader to this sphere. I want to customize how it behaves with light. So I've selected the sphere, and now I want to add a new shader to it. Adding a new shader just means that I want to gain access to the properties of the surface properties of the sphere. So if you remember from the slides, we had different surface properties like metallicity, roughness, and we had anisotropic rotation, sheen. We have index of diffraction, transmission, subsurface. So we have these different material properties, and we can change them and see how our sphere reacts to the light as we change these properties. So make sure you are in EV. Excuse me. Make sure you are in EV rendering engine, and start changing the metallic slider. You can see that our sphere grows darker as we add more metallicity. We can even change the base color. Currently it's white, but if you click on this white section, you can change it to anything you like. Let's say I want to make it slightly yellowish. Now our sphere is slightly yellowish. Let's try to make it a little bit more of a gold color. So now our sphere is slightly golden in color, and I'm trying to make it look more like a gold, more like it's made of gold. So how do I do that? First of all, I want to make it look very metallic. So now it looks a little bit more like gold. Then I want to reduce the roughness. So if you increase the roughness, it will look very diffuse, and if you reduce the roughness, it will become more and more shiny. So this looks a little bit more shiny now. Also, if we want our metal to really have proper reflections, then in the render properties property panel, we will have to enable screen space reflections. This checkbox over here. If we disable screen space reflections and then enable it, you can immediately see the reflection of the plane beneath the sphere show up in the sphere. So it looks a lot more realistic now. It looks like it's made up of gold. Maybe we can increase the roughness a bit, and you can see that the reflection becomes a little more diffuse. And if we decrease the roughness, the reflection becomes a little more defined. So this seems like a good sweet spot for gold metal. And similarly, we can customize our ground plane as well. We can customize our ground plane by selecting the ground plane and then clicking new, and then we can similarly edit the colors of the ground plane. Let's say I want to make it black. I want to make it a little darker, not black exactly, and I also want it to look metallic. So I want it to look very metallic, and I want it to look a little less rough. So now you can see the reflection of our gold sphere in the metallic plane, and it kind of looks like you can create a beautiful render out of this as well. So I hope this gives you an idea um, of like adding shaders to your objects, creating meshes, adding shaders to your meshes, and like rendering them, adding lighting to your scene and rendering them. So I can duplicate this lighting by selecting it and pressing Shift D, like we did while editing the cube, and I can duplicate that light by pressing Shift D again, and now we have 3 lights in our scene. We can even edit the properties of that lights by selecting that light and going into the light properties, and over here we can increase the radius of that light, for example. So if it is a bigger light, it will look much more it will look much more soft on the sphere if we use a bigger light. So I'm using a bigger light and moving it a bit far away. So now you see that our scene has pretty good lighting, and it looks like well lit, and it looks pretty aesthetic as well. So this is how you can like create pretty renders in Blender. So this was just a small example. Tomorrow we will be creating a much more complex scene. I'll show you a preview of that scene right now. So can you guys see my screen? Can you guys see the Windows Explorer?
Yes.
Okay. So this is the photograph. This is an actual photograph that will be referencing, and we will be creating this scene in Blender tomorrow. So in tomorrow's session, I hope that we'll be able to create this scene, and you guys will be able to follow along. So it's crucial for you to install Blender today, and if you are like having trouble getting your hands used to Blender, I suggest you to view the recording of today's session again and like practice along a few times, and I'm sure like you will get the hang of it pretty quickly. So tomorrow we'll be creating this scene, and you guys will be able to render it, and yeah, that's basically what we'll be going to do in tomorrow's session. So let's see how much time we have left. We still have 15 minutes, so let's also look at. So currently we have like set up our scene really nicely, but let's now look at how we can like actually create a like final render out of it. So to create a final render out of it, we have this camera looking at the scene, and whatever this camera sees will be what our final render will show. So if we go ahead on the render menu and hit render image, This is what we are getting right now. So it's not very nicely framed, right? So we can close this Blender render window, and we can come back to our scene. And let's say we want to view the sphere from here and not from here, because our main light is situated over here. So let's say we want to view the sphere from this angle. How do we do that? To do that, all we have to do is press Ctrl, Alt and number pad 0. If you do that, the camera will um, like move itself to align to your current viewport view. So your current viewport view will also become what the camera will see. So whatever you see inside this rectangle is what the camera will see. So now if you hit render, you see that is exactly what the preview showed us. Now if we want to fine tune it a little bit more, we can select the camera by clicking on the edge of the rectangle. Now the camera is selected, and we can press G again. Like G is the shortcut to move, if you remember, and we can move it around. We can move our camera around, and let's frame it something like this. This looks pretty good, and let's go ahead and hit render. So this is what we have right now. We can also, like, currently our world is a bit gray, so that is why when we hit render, we see all this gray background. We can change the color of the background by going into the world properties tab, and we can select the color. We can select the color, and we can move it all the way to black. So now if we hit render, we see the entire background is black, and we have our scene in the middle which we wanted to render. So this is what this scene looks like in Eevee. You can also render it with Cycles render engine by switching to Cycles, and it will take a moment to calculate, but you have rendering with Cycles render engine is slightly more complicated than Eevee, because then you have to worry about all these render settings and whether you want to use this CPU or GPU. So currently I'm using CPU. If you have a GPU, you can select GPU compute as well, and then if you move around, it will render much faster since it's using your GPU. But currently I'm going to use my CPU, just so you guys can follow along as well. So in my CPU, I want the viewport max samples to just be let's say I want it to be 16, and I want the max samples for render to be 32. So what it basically means, so the higher the number of samples, the less noise you will see. So you can see some noise over here, right? If I zoom in, you can see some noise that clears up over time. So the noise clears up because Blender is taking more and more samples at each pixel. So I want the samples for each pixel to be maximum at 16 when I'm viewing in the viewport, and when I'm rendering, when I'm clicking on this render button, I want it to go up till 32, because that's my final render. I want it to be noiseless. So if I render it now, you can see that it's clearing up over time. Currently I'm at 25 samples, 27 samples, 31, and it's almost done. So this is what my final render looks like with Cycles render engine, and you can see it looks a little bit more lifelike, a little bit more photorealistic than what it used to look with the EV render engine. So that is a trade-off that we have to look into. Using EV, we get really fast renders, but we don't really get a very photorealistic render. You can get photorealistic renders with EV as well, but that requires a little bit more finesse. It requires a little bit more work put into it. But cycles right off the bat, you can get pretty photorealistic looking renders. So let's go ahead and close that. And if you have denoise selected, if in the render properties you have denoise selected, then after finishing the render, it will run a denoising filter on top of the image. So all of these noise, all of these grains that you see, after the 30-second sample, it will smooth those out. Like it will create a very smooth image. So look carefully. Right now you'll see a grainy image, and right now it's running the denoiser, and now once it has run the denoiser, it looks very smooth, and it has like gotten rid of most of the grains. So that is something that you can take advantage of while using cycles. Um, we can, like, even if we have not run our ray tracer, if we have not run our path tracer for very long and we still have a grainy image, you can run the denoiser and you can get a relatively clean image from a grainy image. So you can save a lot of time. Let's see if you guys have any doubts. Right. So we are almost out of time. So that's basically how you render. And once you, like, let's switch back to EV so that we get a quick render. Once you render the image, you can save the image using the image drop down and then clicking on save, and then you can go ahead and select the path you want to save the image to, add the name, and then you can click on save as image. So yep, that's basically what how we create renders in Blender. And I urge you to like tinker with stuff in Blender today. You play around with the windows, play around with the tools you have, and tomorrow we will create this champagne render, and I hope you all will be able to follow along with me. And yeah, I hope you enjoyed today's session, and I hope to see you tomorrow as well. Do you guys have any doubts? If you don't have any doubts, then you can leave the meeting, and we'll see you tomorrow. Thanks a lot, everyone. Okay, I see a doubt right now. So the doubt is how to rotate the cube along the edge. Okay. So okay, let me open up Blender. So these kind of things we'll be discussing tomorrow as well, but since you have asked, I'll give you a brief tutorial. So let's say I've added a cube somewhere over here, right? And I went into edit mode, and I want to rotate this cube along this edge. So how do I do that? If I want to rotate this cube along this edge, so first of all, I press Shift S, and once I press Shift S, I get this pop out, and in here I can select cursor to selected. So what it basically does, it brings the 3D cursor onto the center of my selection, which is currently this edge. So now you can select the entire cube, and you can, once you've selected the entire cube, you can hit period or you can hit full stop on your keyboard, and it will bring out this pop out. and in here you can select where you want the pivot point of your cube to be. So currently it's set to the median point. So if you rotate the cube, it will rotate around the median point of all the vertices. But you can select it to be the 3D cursor, and now if you rotate the cube, it will rotate around the edge. So let's say I want to rotate around the x-axis, it will rotate around the edge. And if you want to go back to the normal way of rotating the cube, you can just press period or full stop on your keyboard and then select median point. And then if you rotate the cube, it will rotate around the median point. I hope that makes sense. Great. Okay, yeah. So that's it for today, and we'll be seeing you tomorrow. Thanks.